Okay, so when we're showing covalent bonding, we're only going to deal with these atoms here, because covalent bonding occurs between two nonmetals, and the nonmetals are found in this corner of the periodic table here. Now, when we do this, we do some diagrams called dot-cross diagrams, and we show dots in one of the atoms, crosses in the other, and that's just to make it really clear where the electrons came from originally. Obviously, this electron is the one electron that hydrogen has. This electron is the one electron that this hydrogen atom has. So, if we draw a H2 molecule, we've got two hydrogen atoms bonded together. We've got one line here showing one single covalent bond, and now we need to try and draw a dot-cross diagram to show how this happens. So this hydrogen atom has only got one electron in its outer shell. It would like to have two to become stable. This hydrogen atom only has one electron, and by sharing a pair of electrons there, this hydrogen atom now has two in its outer shell, and this hydrogen atom also has two in its outer shell. So both atoms are stable, or they're happy, and you've got a molecule. Let's have a look at some more examples. Chlorine, there are obviously two chlorine atoms in the molecule, so there's chlorine, and let's show what happens with the electrons. So this one has 7 electrons, it would like to have 8 electrons in its outer shell. So there you go, by drawing them together like that, this atom has 8 in its outer shell, this atom has 8 in its outer shell, so those chlorine atoms are both now stable. For carbon dioxide, it's a little bit different. You'll see that I've drawn the electrons in a slightly different position here. That's because carbon dioxide has a double bond. If I were to write the structural formula for carbon dioxide, it's double bonded to one electron, double bonded to an oxygen, and here it's also double bonded to another oxygen. We can kind of predict whether or not you're going to have a single or double bond by the group that the atoms are in. Carbon's in group 4, so it will have 4 electrons in its outer shell, so it will want to form 4 bonds. Oxygen's in group 6, so it needs another 2 electrons in its outer shell, so it will form 2 bonds. Carbon forms 2, carbon forms 4, this oxygen forms 2, and this oxygen forms 2. So if I just move these around a little bit now, you can see that carbon only having 4 electrons in its outer shell is not stable, but if it bonds onto that oxygen, now carbon has 1, 2, 3, 4, 5, 6 electrons in its outer shell. As soon as it's bonded with the other oxygen, it now has 8. So carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons. But carbon is happy. The oxygen that previously had 1, 2, 3, 4, 5, 6 of its own electrons now has 8 because it's gained 2 from the carbon. It should really try and show that the dots are on the line of both of the atoms there, so they should be overlapping. Okay, so that's a carbon dioxide molecule. Let's have a look at oxygen. And again, we know that oxygen's in group 6, so it's not stable at the moment. We've got one oxygen atom there, it's got 6 electrons in its outer shell. Let's just draw a structural formula. We've got oxygen double bonded to another oxygen. Again, 6 electrons in the outer shell. They share, here we go, 8 electrons in the outer shell and 8 electrons in the outer shell. So where a single bond was the sharing of 2 electrons, a double bond is the sharing of 4 electrons. Single bond, 1 pair, double bond, 2 pairs. Methane, we know that it's got 1 carbon, 4 hydrogens, so we could say carbon, hydrogen, hydrogen, hydrogen. you notice that we don't always draw the hydrogens. Sometimes these lines are just left blank. Hydrogen's so common, sometimes we just leave them blank, so there'd be a hydrogen there as well. So carbon is going to bond to these hydrogens. This hydrogen becomes stable. It has 2 electrons in its outer shell. Carbon still isn't quite there, so you've got 5 at the moment. Let's move that hydrogen in. Move that one in. And move that one in. When you do this on paper, you'll need to fiddle around a little bit and play around with where you actually draw the electrons. You have to move them around a little bit to get them to fit on paper. So that was methane. If you have a look at ethane, it's got 2 carbons. So if I draw this one, I've got carbon bonded to a carbon. So there's my 2 carbons, and they've also got 6 hydrogens. So I'll just draw the lines here. That represents single bond to 1 hydrogen. Single bond, single bond. There you go. That's 6 single bonds to hydrogen atoms. So I can play around with this now and try and get. So I'm going to need another carbon, so I'll just duplicate that one. Carbon is bonded to another carbon. I'm going to need a few more hydrogens as well, so let's put those down there. So first, there you go, and that's an ethane molecule. Ethene, slightly different. Again, it's got 2 carbons, but this time they're double bonded together. So this was the carbon I used last time for single bonds, where I've got the electrons at the corners. But with the carbons here, I've moved these around a little bit so I can try and show the double bonding. So there are my 2 carbons with a double bond. Carbon, double bonded to a carbon. Now there are only 4 hydrogens, so there are 2 for each molecule, for each carbon atom. And again, if we look at the rule, carbon group 4 forms 4 bonds, 1, 2, 3, 4. 1, 2, 3, 4. So let's have a look. Let's try and add on some hydrogens. There's one, 2, and even though that's a little bit messy, you should be able to see that that's a C2H4 molecule with a double bond. A double bond, remember, is the sharing of 2 pairs of electrons. Of course, that's 4 electrons in total. Right, hydrochloric acid. Chlorine's in group 7. 7 electrons in its outer shell. It needs 8. Hydrogen has got 1 electron in its outer shell. It needs 2. So by arranging them like this, they are sharing a pair of electrons, and hydrogen's happy, it's stable, it's got 2 electrons in its outer shell. Chlorine has now got 8. A nice way to remember this is covalent bonding is sharing of electrons. Covalent, caring, cut, covalent, caring is sharing. There we go. Right, so water, we've got oxygens at the centre of this atom. So if we draw oxygen, and there are 2 hydrogens coming off it. Here's my oxygen, and let's put those hydrogens on there. 1, 2, we have ourselves a water molecule. There you go. That was covalent bonding.